So now let's look into actual activity in this. So let me get into this. So installation and configuration of Zap is done. So now, oh, okay, this is we have seen persisting a session. So anyone you can choose. We have gone with S. I want to persist this session, but I want to specify the name and location. That's what we have done. And after that, UI we have seen. Then we will begin with running an automated scan. Okay, we will do that. We'll run one automated scan, that too to my website. So let me come here. So here, just come to this working working dash or working window, and this just click on this automated scan. So now this work pane will be changed to the automated scan. So it's very simple. So the easiest, it's a pretty simple to use this. It's nothing much. We have to just get into this window, and in the URL to attack, you see that in the URL to attack text box, enter the URL of the website, web application you want to attack. Then just click on the attack. That's it. It's pretty simple because it's all automated. Okay, so what I'm gonna do is, so I'm getting to my website. Yeah, so you see that. So this is my website. I have designed this website. Let me scroll this slowly. Yeah, okay, and this website I'm gonna attack. I'm just showing it to you. Okay, this is what I'm gonna. Okay, I'll attack this website. So just let me copy this link. Yeah, and get back to our here and paste it here. So this is the URL I want to attack, and nothing much to do, just read here. So this screen allows you to launch an automated scan against an application. Just enter its URL below and press attack. Please be aware that you should only attack applications that you have been specifically been giving permission to test. Okay, this is my application, that's why I don't want to attack any other websites. So that's why I'm using my personal website to attack. So now attack, just click on attack here. Use a Zack spider. I have selected this, and use a traditional spider as well as a Zack spider. So and then click on Firefox Atlas. Okay, and whatever you want you can choose. I'll go with the Firefox Atlas, and I'll click on attack. So attack start. It start getting the responses from our my application. You can see that, and then the scanning has been taking place. It is in progress. 82% has been completed. Almost all URLs found. Notes added new. So failed to start or connect to Firefox headless. Is the browser available supported? Okay, yes. So now it's yeah, you can see that current scans, it's a rescanning again. Now let's see what's going to happen this time. The last time it's unable to connect because of the browser that we are using. That's okay. Now let's see that number requests 278, current scans just 2, and it's going on. And here you could see the sent messages. These are all the requests. These are all the sent messages. And here you could see the filtered messages. At this moment there is nothing. Let's wait for that. Let's wait for the things to be completed. So It's by and large going into the each and every directory. Okay, it's using get method, post method, everything. It's by and large entering into the each and every URL of my application which is there in the server. Let's see what's going to happen. Let it go on. Let it go on. So it's scanning each and every item in my web application, each and every item in my web application. Okay, 200. Okay, that means it's responding well. So it's getting a good response. Mode permanently. Okay, something is mode permanently 301. Okay, and something is not found. Okay, let's wait for that. It's 18 percentage and it's going on. So 978, 988. So a lot of numbers has been requested. So 1000, more than 1000 requests has been sent to that application, and it's fetching each and everything, each and every item of that, each and every item in that application. So JAP is proceeded to crawl the web application with its spider and passively scan each page it finds. Then JAP will use the active scanner to attack all of the discovered pages, functionalities, and parameters. So JAP provides two spiders for crawling web applications. We can use either or both of them from the screen. So we have used both. One is use traditional spider and second one is a Zap spider. So the traditional JAP spider, here you can see that the top one, the traditional JAP spider which discovers links by examining the HTML in responses from the web application. So this spider is fast, but it's not always effective when exploring an Ajax web application that generates links using JavaScript. So that's the reason for Ajax 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 applications. JAP's Ajax Spider is likely to be more effective. This spider explores the web application by invoking browsers which then follow the links that have been generated. The Ajax spider is slower than the traditional spider and requires additional configuration for use a headless environment. Firefox headless we have gone. So JAP will passively scan all of the requests and responses proceed through it. So far, JAP has only carried out the passive scans of our web application. If you see all our passive scans. So passive scan does not change responses in any way and is considered safe. Scanning is also performed in a background thread to not slow down exploration. So passive scanning is good at finding some vulnerabilities and as a way to get a feel for basic security state of web application and locate where more investigation may be warranted. And other type is active scan. You can see that this one on the screen. An active scan, however, attempts to find other vulnerabilities by using known attacks against the selected targets. Active scanning is a real attack on those targets and can put the targets at risk. So do not use active scanning against targets you do not have a permission to test. So that's the reason I'm requesting, if you do not have your own website, you can use some sample websites to target, but don't use that active target. In spite of that, use a passive target. Okay, it's a humble request to everybody whoever is doing this, is this targeting. Okay, don't target a website which you do not have a permission to test it. Okay, it's pretty important point from my side, you to be noted. So it's completed, the attack complete. You can see that, and some information here. Server leaks version information, you see that. After attacking it, we got to know that server leaks version information via server HTTP response header field. So risk is low, though the risk is low. And here you can see that evidence is this. So Apache and Apache 2 is the version that we have used, that I have used to serve this application, and then Ubuntu is the one I have used it. And here is the one that is leaked. Okay, if you have a doubt, I am going to show you that also. And see, this is the server that I used. Okay, let me scroll down. Yeah, my platform is Ubuntu. Yeah, my image ID. And if you want AMI name, my name Ubuntu image s hvm ssd Ubuntu Bionic. So that's it. Hence proved, just using a Zap, you can target the application and you'll get to know the problems, you'll get to know the vulnerabilities and security threats. So server leaks a version information in this case. So that's how you can find out. Of course, the source is, this is passive. This is not active one. The passive one, 10036 HTTP server response header. In that we got this. So description, the web application server is leaking version information via the server HTTP response header. Access to such information may facilitate attackers identifying other vulnerabilities. Your web application server is subject to different kind of things. Let me scroll down. So now what's the, how to solve that? Okay, before we see that, before we look into the problem and the solution, so what we are going to do is how to interpret your test results. That's the next question. How to interpret your test results. As a Jap spiders, your web application, either one, the crawler, either you can use a traditional spider or Ajax spider. That's what the spider, that's what the crawler we used to crawl across the web application. So it constructs a map of your web applications pages. Let me show that the map. Let me click on select, and here you should see the complete, this is the site. Inside that you can see the all the items, all the items. Okay, you see that from top. Let me, yeah, this is the site. Inside the sites, this is one site I have attacked, and on that site, and here you can see that information. Okay, all the information, everything, whatever is there in that, exactly you can see that. From CSS code, download, icons, image, JavaScript, lib, and more and more and more. Okay, let me close this. So these, then here you can see that tree diagram. Let me click on, you see that it's a orange flag. But before we get into that, first you see the tree diagram. Then it records the requests and responses sent to each page. I'll show you that. These are the requests that are sent, and these are the response that we got. Request get HTTP. This is my website URL, and this is the HTTP 1.1 version, and host is this, my subdomain name, and then domain name, then user agent Mozilla, that's what the agent it has used. Yeah, this is the request, and this is what the response we got. You see that in response you can clearly see in header response, first one is fine, no issue. Then this is the date, no issue. Then the server information, you see that it's giving server information. That should not be the case. And after that, each tag accept ranges content content length, encoding, all those all those are fine. And here you can see that a complete code itself, we got it, complete code. Yeah, complete source code of my web application. But that's fine. So now let's see explored pages. This is the history, alerts, and active scan. These are the active scan pages. These are the explored pages. Let me scroll up, scroll up, scroll up. And we can see the each page request and a response. Let me completely scroll up to the top. Yeah. So this is the first page. It scrolled, it crawled, and the request you can see for this page. Okay, this is the request of that portfolio 2.jpg. That's the request, and the response you got, you see that, you can see that image itself, that's the response we got. Yeah, okay, Let me see that. So uh, to examine a tree view of the explored pages, click the Sites tab here. This is the Sites tab. In the tree window, you can expand the nodes to see the individual URLs accessed. Let me click on that. You see that individual URLs accessed. First one is get forward slash, second one is get CSS, then get download, then get image, get JS, get lib, and last one is get robots.txt and get sitemap.xml. These are the different individual URLs which are used by our Zap. So now we'll just look into the alerts type. So we'll view into the alerts and alert detail. So if you see the left hand side of the footer, you see that this portion exactly at the bottom. Focus on the bottom, leftmost bottom here. So the left hand side of the footer contains a count of the alerts found during our test, broken out into risk category. These risk categories are: first one is high, second one is medium, and third one is yellow, light yellow. It's low. Then the fourth one is informational. Then fifth one we do not have here. The another one we have is a false positive. At this moment we do not have, but normally we'll have a false positive also. So out of my all alerts, I got 0 high priority alerts, 6 medium priority alerts, and 3 low priority alerts, and 4 informational priority alerts. Okay, so to view the alerts created during our test, just click the alerts tab. Let me click alerts tab. Here you can see that alerts tab. Now in the information window, this is our information window. In this information window you'll find the alerts tab. Then click each alert displayed. So these are the alerts that were found, and here you can see the total 13 alerts. 6 plus 4 plus 3, 13. So now let me see, you can see that's all alerts here. Now click on each alert displayed in that window to display the URL and the vulnerability detected in the right side of the information window. Let us begin with the absence of anti-CSRF tokens. And here you can see that this is the URL, and risk is medium, confidence is low, not that issue. CWE ID and VASC ID you can find out there. And this is passive. And here is the description. What's the description of this? No anti-CSRF tokens were found in a HTML submission form. So this is a submission form that I have attached at the bottom. Let me show that. Yeah, this HTML submission form it's talking about. And this is my portfolio: GitHub, Docker Hub, HackerRank, YouTube. Okay, this that's what it's talking about. So yeah, and here you can see that form also. Exactly, you see that form, the form tag. Now then, so this makes a cross-site request forgery is an attack that involves forcing a victim to send an HTTP request to a target destination without their knowledge or intent in order to perform an action as the victim. So the underlying cause is the application functionality using predictable URL or form actions in a repeatable way. The nature of the attack is that CSRF exploits the trust that a website has for a user. By contrast, cross-site scripting. So other information, if you want to see, here you can see that more information. Then what's the solution for that? That's the next question that arises. The solution for this is phase is architecture. Where you need to solve this, you need to solve this at the architecture and design. When you're designing your application, use a vetted library or a framework that does not allow this weakness to occur or provides constructs that make this weakness easier to avoid. For example, use anti CSRF packages such as the OWASP CSRF guard. Of course, CSRF is pitching about their product. That's don't take it that seriously. Let them do. So, if you want to see references, and here you can go into the references to find out the more information about that. And down alert tags, these are the alert tags key and their values. And similarly, we have few more here. So at the same time, the second alert that we have here is again, this is also medium type. You can see that it's a medium type, and what it's saying, it's application error disclosure. This page, the problem here is this page contains an error or warning message that may disclose sensitive information like the location of the file that produced the unhandled exception. So this information can be used to launch the further attacks against the web application. So the alert could be false positive if the error message is found inside the documentation page. So there is a big issue here. So how to solve this? Review the source code of this page, implement custom error messages, consider implementing a mechanism to provide a unique error reference or identifier to the client, so while logging the details on the server side and not exposing them to the user. That's the fantastic. At least you have to provide some login so that it won't be exposed to the external environment or to the hackers. So now, after clicking this alert, you can look into the workspace window here. The workspace window, click the response on this. Let me click on the response. Yeah, now to see the contents of the header and the body of the response, the part of the response that generated the alert will be highlighted. And here is the parent directory. This is where the problem came. Now let me select the one more thing, and here the issue is content security policy. And let me click on response, and this is where the issue. Now directory browsing, and here is the parent directory. That's where the issue. Then directory browsing another, and here is the title. It's the issue is at the title index of /css only. That's Apache 2. It's possible to view a listing of the directory contents. Okay, other people can see the directory content only directly. So there are a lot of issues with that. A lot of issues. Then we have content type header is missing in this. This is one more issue. So it's informational. It is not that serious. Okay. The solution is ensure each page is setting the specific and appropriate content type value for the content being delivered. Okay, that's the informational one. Okay, and the server leaks version. This is very important. So okay, this is very important. Let me get it here. So here you see that this is the problem, Apache /2.4.29. That's the server, and that service we have installed in our server, and that's been leaked. So this is pretty low. That's okay. But the issue here is, it's important one. The web application server is leaking version information. You see that server HTTP response header, it's leaking this version information 2.4.9. Access to such information may facilitate attackers identifying other vulnerabilities. Your web application server is subject to various vulnerabilities. Okay, so solution: ensure that your web server, application server, or load balancer, etc. is configured to suppress the server header to provide generic details. That server header, it should be suppressed. So the server header should not be shown at any cost. So that kind of a solution, that kind of solution we have to take. That kind of action we have to take. Okay, so that's all about the various alerts and information, and the request response, and then let me click on the response, and these are the alerts, and these are the different types of alerts. And the spider, this is the spider. It's a manual. This one is a traditional spider which crawled across our website, and the other side we have a Ajax spider, which is the latest one, which can, if it is a Java based web application. And here is the alerts, and if you click on the history, you can find the history information, and even at each URL you can find out the problem. Okay, what kind of alert, what kind of flag has been raised at the each URL in the tree diagram. You can see that. Everywhere you can find out. Either you see that in each and every image. Okay, this is what the issue with this image. So, and see, spider has crawled each and everyone, each and everything in that. That's what the tree diagram. That's what the tree diagram. And that's how we scan, we attack, and we find out the vulnerabilities. This is automated scan.